So I'm having a little problem with the projector, unfortunately, so my slides are cropped. Sorry about that, but it seems like there's nothing I can do about it now. So I'm going to present the effort for Akonadi Next, the next iteration of the KDPIM search infrastructure. So first, what's Akonadi? The premise of Akonadi basically is PIM data as a service. So it decouples the UI from the data. It provides offline capability, and it provides a standardized interface for applications. So for instance, multiple calendaring applications can reuse the same data, and they can share the whole synchronization that is handled by Akonadi. So to the first cropped picture. Here we see the monolithic application that we used to have. In there, we implemented all the data access, so the IMAP protocols, all the different protocols, nothing was shared. So that was redesigned to our current model that we have in Akonadi, which is with a central server and the resource backends down here. So multiple applications can share these resource backends, they share the same data. Yeah, that's what we're currently working with. This design, however, brought a couple of challenges. So what we see is high complexity in the applications using Akonadi. We have, due to the data agnosticity that Akonadi has, we have performance problems because we have to load much more data into the applications than we should have to. And writing non-trivial resources, so the backends that access the servers, has become really, really difficult. So seeing all this, we started to look into new designs, how we can improve upon that situation. Oh, sorry, I missed the slide. So yeah, we see due to these problems, slow startup times in applications because it has to do a lot of initial processing. We see high memory usage because we have, for instance, if you look at an email folder that has 200,000 messages inside, we need to load them all to be able to do the threading and the sorting, and that just takes time and it takes memory. Due to that, we also see highly optimized code in places where it shouldn't really be necessary. We have to highly optimize because we have to load so much data and because we have to quickly process so much data. As a result of that, we have high maintenance costs because the code gets very complex, and it's become very, very hard to add new features and extend what we have. So with Akonadi Next, we have a serverless design. We have applications that share the separate resource processes still, but each application has direct in-process access to the data, and each client application connects to all individual resources that are available. So let's look at some of the challenges that we have in current Akonadi and how Akonadi Next tries to attack them. So as said, the performance problems we have in Akonadi are mostly that we have to do more work than we should have to. It's not that the loading of the data is slow, it's very efficient, but if you have to load so much data, that just takes time. So this is the basic design of Akonadi Next. So you have a client process. That's the client process. These are the resource processes. What we have the client application that works against the facade, which abstracts the whole storage. So to clients, it still looks like it works against the unified storage. The facade itself loads various plugins for the different resources. It works with. The database that we have is shared between the resource process and the client process, which allows the client to load the data directly from disk. It doesn't have to access the resource first. The part that we unfortunately don't see is the synchronizer here. That is the single writer to the database. And the client then simply writes to the resource if it wants to modify something, but more on that later. For storage, we are currently using a key value store instead of SQL because we're not doing a whole lot of SQL. We're basically storing objects in the database. And the key value store that we're using, which is LMDB, has some nice performance properties. So just to give you a rough idea, on my laptop, I can write about 150,000 2K values per second and read at about 400,000, which are individual kiloops. So even if we still had to load all the emails in a folder, that would be done in half a second or so. LMDB also provides transactions and it supports multi-process usage, which is precisely what we need for such a project. And as the other significant change, we have now one database per resource instead of one unified database. To store the data, we have the key value store. Each value is split into 3 parts. We have a metadata part where we store stuff like revision, ID, access times, stuff like that. And then we have a local and a remote part. The idea of that is that we can provide a default implementation for the local part. So in here, for instance, if you store an event, in there we have the start date, the end date, the summary, all the standard properties that you have that are shared, that are most likely shared across different resources implementing events. The remote part is where resources can customize. So for instance, the Collab resource stores events in IMAP. So we have IMAP-specific synchronization properties that we need to store somewhere. So that's UID next. And various other values that we need to be able to efficiently synchronize. The resource can freely define that part and add its own properties there. It can also specialize the values that are already available here if it would need to somehow be able to store it more efficiently. But by default, you don't have to do any of that. So with that, we have a fast storage, but what's really the aim is to only load the data that we really have to, so to reduce the work that we have to do. And for that, we need indexes. So what we want to be able to do is to, for instance, if you load the calendar, you look at the specific week, we want to be able to only load the events that actually affect this week. Because currently we have to load all calendars into memory to figure out what we actually want to display. So we want to index that. For that we need various indexes, like full text indexes for searching, we need date range indexes for events. For emails, we need threading indexes to be able to do the sorting, so you can only load the top 200 emails instead of 200,000 that you're never going to look at. So if we achieve all that, what we get is really fast startup times, because you basically don't have to do any work. You're just rendering the state from the database. We have low memory usage because you don't have to load anything into memory. And we don't do repetitive, expensive processing. So right now, if you click on a folder, we load all the data, do the threading for all the emails, and we do that every time you click on the folder, which is naturally expensive. If we do that in indexes, we have the opportunity to persist that processing and then incrementally update that as new items come in. So the next problem that we have is, and perhaps even the larger one, is complexity. Applications built on top of Akonadi sometimes feel a bit like a Ruben Goldberg machine, where you touch one thing and then something happens there and something happens in the next place. It's very hard to debug it and to know what's actually going on. With Akonadi Next, we're trying to attack that problem by using a more reactive approach. So a large part of the problem, I think, is that we are working with multiple mutable states that interact with each other. And if you have multiple such states, you need to test basically, or you need to consider each combination of all these states to be able to reason about what the program is going to do. So in the reactive approach, you try to confine this mutable state as much as possible, which would, in our case, be the database in Akonadi. So the presentation simply renders that state, and it sends commands to modify that state. And once the modification is done, it reacts again to it. That's a lot easier to test, and it's a lot easier to reason about. So, in the resource overview, we see these reactive loops. So here, that's the resource process. So clients send commands to the resource, they end up in a queue. The pipeline, to which I'll get shortly, simply processes this queue one message at a time. And once the processing is done, the result ends up in the database, so it modifies the state, and then notifies the client, or respectively the clients, about the change. On the other side, we have basically the same loop for the synchronizer. So the synchronizer figures out the change set that it has against the source. The source is, for instance, the IMAP server. It then generates a change set that it also sends into the queue. And again, the pipeline simply processes those queues, picks up the commands, and once it's done, it publishes that state to the system, and also, of course, it sends the change set to the write back to the server. So everything is in sync. But that way you have basically this single flow of information. So the pipeline is a series of steps that are guaranteed to be executed, where it can do various things. The most basic thing that we'll want to do in here is updating the indexes. By doing this in there, we can guarantee that as soon as an entity enters the system, the relevant indexes are already up to date. But we can also do stuff like mail filtering in there. So we can, for instance, filter mails to other places before they enter the system, so they don't pop up in your inbox and then vanish somewhere else. They will be moved into the right place immediately. We can do also various other things like spam virus detection in there. We will have to do conflict resolution in there, because that's the place where we can, where we notice if a change actually still applies to the current database state. The last problem that we have is the impedance mismatch that we have between the source on one side, so for instance, the IMAP server or your groupware server, the domain model that Akonadi has, which consists of collections and items, and then the domain model of the application. So if we look at the current domain model, slightly simplified, we basically have collections, and collections can have entities, which are collections or items. So you have this simple folder hierarchy. Additionally, we have flags and attributes, store stuff, basically. And the payload we can more or less ignore for this. But this is used for a storage model, and it's used for data access. So whatever the resource gets from the server, it has to fit it into this model. And if this is not a one-to-one mapping, which we face, for instance, with tags, then the synchronization code becomes very, very complex. And the same problem you, of course, also have on the application side. If the application domain doesn't map one-to-one on this model, then you run into problems. So with Akonadi-Next, the domain model is supposed to be both simpler and more expressive. So the main part of the model is this. You have entities, and entities have properties, and that's it. That's what is used for storage, and that's what we cannot really change. That's by design. But that system should be flexible enough that I think we can map everything into that. But on the client API side, we need to be more expressive. We need to allow applications that they can query for calendars. They shouldn't query for collections and then everywhere in the application assume, oh well, that's a collection with this MIME type, therefore it's a calendar. So currently we're always making implicit assumptions about how, for instance, a calendar is represented in the database. With Akonadi-Next, we want to have a cleaner way to define that. So we, for instance, define, well, we have collections and we have various types of collections. For instance, we have calendars. And for instance, a calendar may have additional properties, like perhaps a calendar has a color while a mailbox does not, or perhaps a calendar has an owner. So that's something that we need to define, because that defines the standardized access to the data. That's what enables various applications to use the same data. So this part is meant to be evolved over time. So if we see, well, we have now a new type that we want to deal with. So at the beginning, for instance, we have events, and then we add to-dos at some point. And the properties we can simply extend to what we require. Because they're not implemented in a type-safe way, that's more by specification. So we, for instance, say an event has a property called start date, and start date is a queue date time, and the interface itself is a queue variant based. So the client API has a minimal set of the necessary operations, which is you can query for data, you can create, modify, or remove entities, and that's it. So 4 calls, basically. The queries are reactive, so you specify what you want to, what data you're interested in. You, for instance, say, well, give me all events from calendar X. And the query then populates itself. That maps then very, very well, for instance, onto models, because you simply define a query, you set it onto the model, and the model will simply populate itself. And due to due to us having now different resources, the client API or this library is also responsible for aggregating the data between the different resources, since we no longer have a unified storage. So for the review, we have the client that works against this facade, which gives the illusion of having a unified storage. The facade itself figures out to which plugins it has to talk. The plugins themselves know how to access the database, and they know how to contact the resource. So if we have a modify command, this command is sent to the resource will process it and modify the state in the database. Once the processing is done, it will notify all clients that something has changed, a new revision is available, and the client can then read the actual data directly from the database in process, which is very cheap at that point. And so because of this design, we're also very flexible to customize per resource. So should we see a need to, for instance, replace the database for whatever reason, because resources do have very different requirements. Some resources deal with high volume data, some resources deal with a bunch of events. So because that is completely encapsulated by the resource, you could even replace the storage, which is definitely not what we'll want to do by default though. So the idea is to provide default implementations for everything. That's writing a simple resource, takes a couple of lines of code, and then the code that you actually need to contact the server, because that obviously we can't do for the resource. But if you have to, you can customize most aspects of how the resource itself works. So, I have a quick demo. I can't see anything now. So let's try that again. So what you see here is just a simple model that is populated by a query. I implemented a dummy resource that works against an in-memory backend. Doesn't really do anything useful. And if I click synchronize, it sends a synchronize command to the resource. It then populates the database with 100 events or 100 entities. And they should... Then we get 100 notifications from the resource that stuff was added, and the model will update itself. Yeah, that's basically already it. So yeah, it's a fresh and modern code base. It uses some new techniques to write asynchronous C++ code that Dan is developing. Go to his talk tomorrow. We have a project on Fabricator to coordinate the development. And you can, of course, always contact me by email or IRC or whatever if you'd like to join the development. Questions?
Hi, thanks. I'm really interested in this research project, and I really want to see it going forward. One problem I could think of is, how did you intend to handle updates to the database on this? Like right now, imagine I changed something somewhere in the layer, like the facade, for how a mail is going to be represented on this. In the current system, I would simply write an update query and add a field or something like that, and MySQL will handle it for me. How will this work LMDB or whatever the custom resources use behind the scenes?
What we're using to store the actual values, each value has a structure. We're using flat buffers for that, which is a system where you can basically write a little schema and then you generate an accessor for that value. And it's very neat together with LMDB because LMDB does memory mapping of the values and you can then basically initialize the struct with a pointer and then access values inside that area. But the other thing that LMDB does is it supports versioning of these values. So you can never remove a value, but a value that is empty, that you're not using, is free. It doesn't store anything there. And if you add new values, you can still read the old versions. So that way we can evolve the storage.
Give you any thought on how to migrate from Akademy 1 to 2? What kind of issues would that be? And the kind of schedule for when you would like to switch?
There's currently no real schedule for when we want to switch because it's in either case going to be quite a large undertaking. And we have to figure out how to swap that exactly. And for migration, we cannot migrate the data because the data sits in the backends. I don't think that would make sense to invest into that. So what we're interested basically to do is to migrate the configuration. So to set up your resources perhaps again. But these would just be separate tools, I guess, that do the migration. I'd like to avoid...
But you're not going to touch data, so that's going to be pretty safe.
Yeah.
Last question. How much work is for the client and the resources to update from Akonadi to Akademy? How much code do I need to rewrite? Oh, I don't think so.
So for the...
Like say Kmail, how much code in Kmail do you have to rewrite to use this?
It depends a lot on the approach we take. I think we obviously cannot rewrite all applications from scratch. For the resources, I think it makes sense to more or less rewrite them because you wouldn't really gain much by trying to maintain backwards compatibility there. For the client applications, the current plan is to re-implement the current API on top of Akonadi Next, so that the switch is transparent to the applications. In the long run, I think the applications can lose a lot of code that we currently have by porting it properly and removing that API. Because a lot of the complexity that we have in the applications, I believe, comes out of the API that we're using currently to access the data.
So thank you again, Christian. I guess for people interested, there are a few both for KDP. So
yeah, there's one on Tuesday, and if you have questions, just grab me whenever.
Okay, thank you again.